Okay, so I accidentally hit the wrong button. So this is just a continuation of the previous video dealing with inverses. So we're going to do another one here. Find the inverse for the function f of x equals x to the fifth minus 3 over 2. So step one, replace f of x with y. So that's what I'm going to do. Step two, swap the positions of x and y. So I get x equals y to the fifth minus 3 over 2. Step three, go ahead and solve for y. I'm just going to rewrite it real quick. Y to the fifth minus 3 over 2. Now, to solve for y, I'm going to multiply both sides by 2. All right, that gives me 2x equals y to the fifth minus 3. Then I'm going to add 3 to both sides. So that gives me 2x plus 3 equals y to the fifth. Now from here, I'm going to raise both sides to the 1/5 power. And that's going to give me the quantity 2x plus 3 to the 1/5 equals y. Step four, I'm going to replace y with the inverse of x and just write it as 2x, the quantity 2x plus 3 to the 1/5 power. So there's our inverse. Now, for step five, stating the domain, I think it's going to be easier for us to look at this as the fifth root of the quantity 2x plus 3. And since this index is odd, we know this is going to be defined everywhere, from negative infinity to positive infinity. So this next example, we just need to be clever on how we do our algebra. That's it. So we're going to find the inverse for f of x equals 2x plus 3 all over x minus 1. All right. So first things first, we know x cannot equal 1 because if x equals 1, we're going to get 0 in our denominator. We can't have that. Step one, y equals 2x plus 3 over x minus 1. All right. Now, step two, what we're going to do is we're going to replace the x's with y's. So I get x equals 2y plus 3 over y minus 1. Now, like I said, we just got to be clever on how we do this. So, step three, I'm just going to rewrite it. We know that we have to solve for y. So what I'm going to do is I'm just going to try to algebraically manipulate this so I can get at least the y variables on one side of the equation. So what I'm going to do is I'm going to multiply both sides of the equation by y minus 1. So that's going to give me x times y minus 1 on the left-hand side. On the right-hand side, I just get 2y minus 3. Now I'm going to go ahead and distribute the x to give me xy minus x equals 2y minus 3. And as you can see, I have a term xy on one side and a term 2y on the opposite side. So I'm going to get them together. So what I'm going to do is just subtract 2y from both sides. So that gives me xy minus 2y minus x equals negative 3. And then I'm just going to add x to both sides. So that gives me xy minus 2y equals x minus 3. Now from here, I'm feeling really good because what I can do here is I can factor out my variable y. Oops, sorry, x minus 3. And then by factoring this out, I can just divide both sides by x minus 2 to give me y equals x minus 3 over x minus 2. And then step 4, just write the inverse is equal to x minus 3 over x minus 2. And you're going to have to excuse me because I did make a little typo. If you go all the way back up to the very start, this is supposed to be plus 3. So luckily for us, it doesn't change anything except for this +3 out front. So all these should be pluses. There we go. So now with this, we need to be careful because we can use any number we want except 2 and x cannot equal 1. Because if you think about it, all the way up at the beginning, you got this x minus 1 in the denominator, so you got to make sure you include that in with your domain. Okay? So the last example I want us to look at real quick will be a situation like this where we have a restricted domain. Even walking into it, you can see it. So I think a really easy example would be this idea of a parabola. So we know this is going to be the function f of x equals x squared. And if we were to go ahead and do the horizontal line test, notice we hit twice. Therefore, this would fail the one-to-one aspect of finding an inverse. However, what we can say is, well, you know what? Why don't we just restrict our domain to just x is greater than or equal to 0. So now you pass the horizontal line test, which you can totally do, but what you got to do is you got to tell us that you're restricting the domain from the very start. So if this is the case, we can go ahead and find the inverse, and the inverse should be, hopefully readily apparent. So y equals x squared. Then I'm going to swap the positions. I'm going to solve for y. And then finally, I'm just going to rewrite the inverse of x has to be plus or minus the square root of x. Now, if you look at this, we have the inverse, okay? But we need to be careful about which one of these we use. So when we look at this, notice that all of our x values and our y values are all positive. So for x squared, our domain is 0 to infinity, and our range is also 0 to infinity. Now, if you remember the definition, all you have to do for an inverse, let me zoom in on this. There we go. So all we have to do for an inverse is swap the positions. So in other words, the inverse for our domain, or the domain for our inverse, I said that backwards, will be, I know this is going to look right, but it's going to be 0 to infinity again, but you're switching them. And then the range will also be 0 to infinity as well. Okay? So you're not going to use the negative part because you don't want anything below the x-axis. You want them all above. So the only one that we really have to be concerned with here is just the inverse of x equals the square root of x. And that looks like this. So if you were to draw y equals x going across the middle, you definitely have that reflection that we're looking for. And in fact, once again, if you come over to Desmos and you were to go ahead and graph, here's y equals x squared. Now, I'm going to shift this like this because there's a way to restrict domains within Desmos, but I forget how to do it. And it's already like 10 o'clock at night. So I don't even want to look it up. I'm just going to shift it over so it looks like it. I'll zoom in for us. There we go. Now we got the square root of x. So notice that's in black. It may intersect right here, but no matter what, we still have that mirror image about the y equals x line. If you were to graph the negative square root of x, all right, you would see that it does not create that mirror image that we're looking for. Therefore, you wouldn't even use it. All you have to use is the positive side. And we use the positive side because our domain and range are very limited to quadrant 1. Okay? So that's going to be it for this video. Good luck. And if you got any questions, just let me know.